Okay, so hi everyone. Hello everyone. So in this problem, we are just going to have a binary search tree which is given to us, and we have to find a particular value in that tree. Now, what is a binary search tree? So a binary search tree is a tree. For example, here it is that the root node is 50, and then left node is 30, and the right node is 70. So for a binary search tree, we will always have that whatever the value is there in the root node will always be greater than the left node but smaller than the right node. So when we search in a binary search tree, which is always balanced, like in the way that left child will be filled before the right child will be filled. So it's a binary search tree, and if you want to search any node in that, so for example, you can see like here in this code we are trying to find 19. So if it finds 19, it will tell us that yeah, it has found it, and if it has not found it, it will tell us that it has not found it. So we go inside this function, it will say okay, I have to find 19. Great. So the root node, which is the root node over here, which is basically mm, the root node of the tree is 50 in this case. So which is not null, and also which is not equal to the key here in this case is 19, the value that we actually want to find out. So what this basically doing is it is trying to search that value. So now it will say that okay, so whatever root dot key was there, root dot key is actually the value 50. So this is the node, and root dot key is the value which is there in that node, and key here represents the item like 50 or whatever the data is there in it. So for it, the data is the key. So here it is 50. 50 is compared to the actual value. So in this case, 19 is not greater than that. So it will search it in the left part because left is always smaller. So yeah, it goes down and it starts searching in the left part. Again, it searches in the left part and it says that okay, it's not equal to the key. So it says okay, now the key is basically 30, which again it will start searching in the left part. So it searches in the left part and it again says that the key is 20, and it's trying to search 19. So again it searches in the left part. So in this case, there is no child root of 20. So it will say that okay, mm, now we don't even have the root node. So what are we going to search it in? And then it will say sorry, as it is null, it could not be found, and we can see that our answer for the first one is that it's not found because it did not return because it gave the value as null. So only if the value is not null say found, as it will return this. Now it's trying to search 80. So 80 is actually greater than 50, greater than 50. So as it is greater than 50, it will say okay, it is greater than 50. Now we have to go and search in the right part. It goes and says okay, the next key we have is 70. Okay, 80 is greater than 70, I will go and search in the right part. So it searches in the right part and it says oh my god, I have found 80 there in the child of 70, and that's why it will return the root node as 80, and as it returns the root node, the final answer, it has returned the value which was found. And the found value is sort of there. So yeah, so it uh, basically gives us the answer, and our answer is uh, yeah. So the key here in this case is 70, and this is 80, and yeah. So it has found 80, and that's why it will say yeah, I found it, and it will enter yeah, it found it. So found is the answer. So that's it for everyone for this video. Hope you liked it.